let's look at the summary measures for a continuous variable. And we've already seen some of these. So in this case, the minimum of the min in Excel is going to be the minimum value of a data set. The Q1 will reference as the first quartile. Q2 will represent as the second quartile. The median, the mean. Again, the median is the middle point. The mean is the average. Q3 for the third quartile. Q4 for the fourth quartile, a max, a variance, and a standard deviation. So given a set of data, the computation is fairly easy. Again, using the grades that we had before, we have the minimum function in Excel, the quartile with 1, a quartile with 2, the median function, an average, quartile with 3, quartile with 4, the max, the sample variance, a population variance if we needed to, a sample standard deviation, and a population standard deviation. These are the values that it computes. Now, a couple of things, frequently asked questions, is the Q2 always the same as the median? The answer is yes. Recall that the median represents the midpoint at which 50% of the data falls below and above. Q2 is the number where 50% of the data falls below. So it would make sense that the two of them are the same. Now, why isn't the median and average, or the mean, the same? And while they will be close, it's not always the case. When we have a bell curve or a normal distribution, the mean and the median will be very similar. In fact, theoretically, they are the same. But in practice, they're always going to be slightly off because nothing is ever purely normal. Now, is the maximum Q4 always the same? The answer is yes, because Q4 is the point at which 100% of the data falls below. Thus, it would be equivalent to the maximum value in the data set. Also, the minimum number would be equivalent to a quartile 0, which people don't use very much. Why isn't the variance of the population and variance of the sample the same? Recall, it has to do with this concept of the correction in the variance for a sample, identified by the change in the denominator, where for a population it's n, and in a sample it's n minus 1. And further, since the standard deviation is the square root of the variance, then the population and sample standard deviations will also be different. Now let's take a look at the box and whisker plots. They provide this snapshot and spread of the distribution along with outliers. Now recall that each quartile can easily be identified by the edges of each region. So Q1 will fall at this point. Q2 and the median are that thick middle line there. Q3 is the end point of that box, and Q4 is the final piece. While they look the same size, they aren't always the same size. If we were to look at a box plot of a normal distribution, it might actually look like this. Now, note that this box and whisker plot was drawn in using R, so it's denoting some of these little circles. Those circles are kind of outliers. They could be turned off, but I don't have them turned off here. But it's made from the same data. And what you're going to notice is that the whiskers are a little bit further out, and they're not equidistant from that center box. Everything is scrunched up because a lot more of the data is within a tighter range there. Now, but the circles to the right and left represent outliers calculated by the Tukey inner fence method. That's what this statistical application uses, and Excel will give you outliers as well. The vertical lines at the left and the right of the whiskers represent the last data points that lie in the inner fence boundary. So thus, the boundary may actually be slightly beyond those actual data points that lie beyond it and are determined to be outliers. So in other words, when it draws the box and whisker plot, those vertical lines are the last data points within the inner fence boundaries, and then you can have your outliers beyond it. So your max might not look like that last line if we had represented it as Q4. The red vertical lines are actual inner fence boundaries. So the red line is the actual inner fence boundary itself, but the line itself from that whisker might be the last data points within the inner fence boundary. So they could be slightly off. Now, when we use box plots to compare multiple groups, it's possible that we can see what's going on between them. We kind of get an idea of the spread of the distribution. We kind of get an idea of what one group is to the other. The first group has a very narrow interquartile range and has its median much higher than the second group. The second group has significant variability and is actually lower than both groups. And the third group seems to have a significant outlier at around 40. And the reason I'm doing this is to show you how the box plots can be used to really understand how to look at data together.